Hello, you are welcome to this class. My name is Dr. Kingsley. In this class today, I will be taking you on the path-dependent nature of work. Path-dependent nature of work. Work is a path function. We have state function, we have path function. Path functions are those thermodynamics functions that their value depends on the path taken. So their value changes as the path taken changes. So examples of path functions is heat and work. So in this class today, I want to prove to you that work is a path function. Now, if we want to do this, we want to first of all say, for example, if we have a gas in a container and this gas begins to expand, this is the piston, initial position of the piston, and this piston, if it is what, weightless and frictionless, and the gas here expands from here to here, you will see that the gas is expanding, so it is doing work when it expands from say point A to point what, B. Now, since the gas is doing work when it is expanding, we know that the value for work done, is equals to pressure multiplied by change in volume. That is the formula for work. Pressure multiplied by change in volume. That means that work is actually equals to pressure. Change in volume is V2 minus V1. That is formula for work. But now let us assume now that a gas expands into a vacuum. So that is the first route or path that we want to take this morning. So if a gas expands into a vacuum, what will be the formula for work done? Now, since the gas is expanding, the pressure that we are considering will be the pressure exterior. That is the exterior pressure. The gas is expanding, so it is doing work against exterior pressure. That means that the work done by the gas will be equal to what? The exterior pressure that the gas is doing work against by expanding, multiplied by change in what? In volume. That means that the work done when a gas expands into a vacuum will be the exterior pressure now is the pressure of the gas, because the gas is expanding into a vacuum. So the exterior pressure is actually the pressure of the vacuum. And we know that vacuum does not exert any pressure. That means the pressure of the vacuum, which is the pressure exterior, will be equal to 0. That means that work done when the gas expands into a vacuum will be the exterior pressure, which is the pressure of the vacuum, multiplied by change in volume. So the work done when a gas expands into a vacuum will be equal to 0. Why is it 0? It is 0 joules, because the exterior pressure is 0, because vacuum is an empty space and therefore it does not exert pressure. So that is the first situation that we have here. So let us go into another situation. Assuming the gas, if the gas expands against a constant exterior pressure. So constant exterior pressure here simply means that there is a pressure, exterior pressure, which might be 1 atm, 2 atm, and so on. So it's not 0, as in the case of a vacuum. It simply means here that the work done will be the pressure of the exterior multiplied by change in volume, which is change in volume. So the work done will be the exterior pressure, okay, multiplied by V2 minus what? V1. You can see with me that what? That the work done here is not zero, because exterior pressure, okay, is not zero, and also there is a volume change. So when a gas expands into a vacuum, the value is zero. When a gas expands against constant exterior pressure, the value is not what? Is not zero. Assuming two of them are zero, maybe you can begin to think that what? That a work is a state function. But since these two values are not the same, it simply means that once the path changes or the route changes, okay, the value of work will change, making it what? Dependent on the path taken. Then that is number two. Then number three is if the gas expands under constant, okay, expand under, okay, if the gas expand, okay, let's say isothermally, if gas expands isothermally and reversibly, what will we get as the value for what? For work. A gas now want to expand, okay, isothermally and reversibly. Now if we consider this case, you will see that what? For isothermal and what? Reversible, that pressure exterior will be equals to pressure interior, because it's a reversible process. Is a reversible process. Isothermal and reversible. Just as when you say that they are in equilibrium. So the exterior pressure will become equals to interior pressure. In this case, work, which is equals to what? P exterior, okay, into V2 minus V1, will now become work will become interior pressure, or P interior, okay, P interior, because interior pressure now is equals to what? Exterior pressure. Then multiply by this is what? The V. But we know that the interior pressure is actually the pressure of the gas. And according to gas law, okay, according to gas law, PV is equals to nRT, okay? That means that P becomes nRT over, okay, V. So if we do this, we can see that what? That we can substitute what? The P interior, which is the pressure of gas, with this, okay? That means that work done in this case will now become, instead of interior pressure, okay, instead of interior pressure, which is the pressure of the gas, we can put this for interior pressure. So we'll be having here P interior, which is nRT over V, then multiply by what? Change in volume, the V. So you can see that this will become nRT, okay, the V over what? Over V. That is change in volume over volume. Now integrating, if we integrate this function, our work will become nRT, okay, integral of what? V1 to V2 of okay, the V over V. That means the work done will become nRT. When you integrate this, you will be having V2 divided by V1. So the work done when the gas expands isothermally and reversibly is this. So in a summary, if a gas expands against a vacuum, in summary, the work done will be equal to zero. If a gas expands, okay, against a constant, okay, exterior pressure, the work done will be the exterior pressure, okay, exterior pressure multiplied by change in volume, Then if a gas expands isothermally and reversibly, we will get what? we get the pressure, okay, the work done to be nRT, okay, ln, okay. It's like I left something here. When you integrate this, it have to be ln V2 over V1, ln V2 over V1. So when the gas expand isothermally and reversibly, the work done will be, when we integrate this, will be nRT, okay, ln, okay, V2 over V1. You can see that in these three conditions that we took, the values of work done differs. That conclude that what the work done is actually, okay, is actually a part function. Now let's take one question before we go. Let's take one question. Okay, a gas expands against a vacuum, and during this process, comma, the volume changes from 10 liter to 20 liter. Find the work done. Find the work done by the gas. Now we don't need to solve anything. So far the expansion is against what? Against a vacuum. It simply means that the work done will be equal to 0 joules. So thank you. Subscribe to my videos, share and like.